Okay, now, you might be thinking with this next one, this is thirds. You might be thinking, I need 3 bubbles. No, you don't have to have 3 bubbles to do this. So if you only had 2 bubbles, and you had to use thirds, what is one thing, one way to do this? Well, exactly. Okay, 2/3 and 1/3. Okay. So we don't have to just have unit fractions in those bubbles, is what I'm saying. So if we had fourths, what's one way we could divide them up? Yay! So that, just drop it in that orange basket. Okay? All right, Mason, what's one way we could do this? 2/4 and 2/4. We're just kind of getting started. Okay, so just get settled and then get out your whiteboard, okay? All right. Now, hold on before we move right here. Is this the only way to do fourths?
No.
No, what's a different way? Yeah.
You could do fourths, and 0.
You could. What's another way? Yeah.
3/4 and 1/4.
3/4 and 1/4. Okay. What about fifths? Let's just throw out a way to make fifths. Go ahead.
3/5 and 2/5.
3/5 and 2/5. And of course, the larger our number gets, we get more and more ways to do this. Yeah.
4/5, 1/5.
Yeah. 4/5 and 1/5. Basically, any way you could make 5 when you're adding. Okay. Turn all the way around. All right. Anything else here? Is there another way? I guess you could do 5/5 and 0/5. And then you could start going, well, we could switch the order and go 2/5 and 3/5 or 1/5 and 4, basically the same problem. Okay. Just wanted to put that out there. All right, before we go on, let's do a practice problem or two. Really? This is still here? Everything's supposed to be fixed when I come back. Does it do that to Miss Elizabeth?
Yeah. Yes.
Okay. Does she go, why does this happen? Does she ask that about my board? Okay. Because I asked questions about her board. Her board does some weird thing where, like, you know how, like, if you're not working on the computer for a while, it'll go black screen? Okay, like, I can only be away from the computer, like, 5 seconds, and it goes black screen. So, like, every time I turn around, I'm having to come over here, and it'll go black. And I'm like, really? The worst possible time, it goes black screen. So she has weird quirks on her board too. Okay, so we're going to do a problem here. Let's do 78 times 42. Okay. There's the dinosaur if you need that to help you. So let's check over this. And by the way, just a little time out here. Good job on the tickets. I'm going to keep doing that, but I'll be the one picking the 2 names every day. Okay.
Now we're doing 2 names.
I brought the sleigh. It's over there on my desk. So, And Caleb, I guess you're the only one that needs to pull out my treasure box. Is that right? Come in here. Okay, so we'll take care of that this afternoon. All right, so 2 times 8, everybody? 16. Put the 6. Carry the 1. 2 times 7? 14. Plus 1, 15. All right, so your top row should be 156. We're done with the 2. The dinosaur lays his egg. 4 times 8? 32. Put the 2. Carry the 3. 4 times 7?
28.
28. No, 28's right, but I'll just, 28, but then add 3.
31.
Nope. Add them up. Oh no. Hurry before I turn around.
I'm gonna go first than you.
What's the answer, Ishmael?
3,276.
Woohoo!
Yeah, go first. Did I do first?
3,276. Okay. Let's do one more problem and then we'll move into our lesson. Yeah, that's what I was thinking. Okay, was it weird? I just have to know, was it weird having a whiteboard up here and the writing just appears?
Yeah.
Okay, because I kept thinking, that has got to look weird, that all of a sudden this problem's on the board. Okay. Anyway, let's go with 573 divided by 6. And then go ahead and check it with multiplication. How many 6s can you get out of 57? Okay. What's the closest we're going to get to 57? With 6s. Kinley, what did you put on the top at first? 9, because 6 times 9 is what? 54. That's as close as we're going to get without getting too big. Okay. So once you subtract, you know what I didn't miss at home?
Your math.
Sorry. I'll be quiet. No, I won't. Okay. Anyway, then we bring down the other 3. Okay, think about your 6s. What's the closest you can get to 33? Yeah. 30. So that's 6 times what? 5. So the 5 goes up here. 6 times 5 is 30. We subtract that and get 3, and there's nothing more to bring down, so it is a remainder. It's too small to be a group of 6. So it's our remainder. So 95 times 6, that's 30. 54, 55, 56, 57. Plus the 3 right here. There we go. Okay. All right, you can clear your board off. All right, well, our actual target today is not on the board. It is here. Practice placing various, and various just means different kinds of fractions on the number line. Okay, have we done that already?
Yes.
We have done that a lot already. Okay, so I want you right here on this board, let's just use this space. Actually, you know what? Let me get more space. I think we're going to need it.
Surprisingly, that's something.
All right, so if I put, hold on. If I put a number line right here, and I said, hey, let's make this into fourths. Okay, how would you do that? Now think back, pull back what we did last week. Okay, what's, how would we get started doing this? What's the first thing?
Cut the number line into 4 pieces.
Okay, when it says fourths, not 4, but fourths, it's written like that, we know we're dealing with fractions. Okay, so we know that this is our denominator and that we need 4 pieces, except, hold on, it could be more than 4 pieces, couldn't it? What if our number line goes from like 2 to 4?
No.
Then we would need to put a 3 on there. We need to put 4 pieces between 2 and 3 and 4 pieces between 3 and 4. Let's just make it simple this time. That is only one whole number. Okay, so like Reagan said, we can cut this into 4 pieces. Okay. And then, yeah, don't worry about doing it right now. We'll do it in a second. Okay. I didn't say it at the beginning, so hold on, we'll do it in a second. All right, so what would go above the 0? 0 fourths. 0 fourths. Gonna squeeze that in there. Okay, so then right here would be 1 fourth. Okay. And okay, and what can somebody tell me about this and this right here? What is that kind of rule thing that we should know? Yeah.
That it's a whole number.
What is?
1.
Okay, what about 1? And what about a fraction like that?
You can multiply 1 by 4 and you'll get 4 fours.
Okay, so 1 times 4 is 4. 4 divided by 4 is 1. So multiply up, divide down. That definitely works here. What else can you tell us? You can. That was something we were doing on that assignment. Every single time we have a whole number, we don't have to box it in, but that helped us recognize those whole numbers. Yeah, what else?
If you have 2 of the same numbers on top and bottom, it's a whole number.
Okay. Not only that, it's a certain number. If you have the same number on the top and the bottom, the numerator and denominator, it will be 1. It won't be 2, it won't be 3, it will always be 1. Okay? Now, if you have, let's say a fraction like this. If you recognize a fact family, and you know you could divide that evenly, no remainder, then it is a whole number. Okay, it's just a different one. It's 12 divided by that little line means divide. It really does, even though it's fractions. 12 divided by 3 is 4. And 4 times 3 is 12. So this 12 thirds is the same as 4. If I had, let's see. Where's my
Third?
Yeah.
It's on your thing over there. It's on your red card. On the pen.
Oh, yeah.
What?
You trying to eat the pizza? Alright, so let me make sure I say this right. If I wanted to get 12 thirds, I would need 4 of these. 4 whole pizzas cut into thirds would give me 12 pieces. Okay. Anyway. Alright, so let's do one of these. I'm going to write it right above here. Alright, so let's do a number line on your board. And let's turn it into, are those number lines the same size? Like, okay. Pretty close? Okay, I'll make sure that this is the same. 0 and 1, right about there. Okay, so you're going to have a number line from 0 to 1. Go ahead and put those whole numbers on there. Okay, let's cut this one into fifths. Actually, yeah, go ahead, fifths. Go ahead and label it. Go ahead and cut it in fifths. I'm letting you do it. If this is fifths, then I could go ahead and write my denominator right, couldn't I? I know my denominator is 5 every time. Okay. I also know I need 5 pieces. Alright, so your number line look like that?
Yeah.
It should. Alright, put the top on your marker for a second. Okay, so yeah. Alright, look at my 2 number lines. Since we've got 2 of them up there. Alright, look at them, and since both number lines are very close to the same size, the zeros, the ones, about, we start at the same spot. Let me pick a fraction. We'll just start with unit fractions. If I said look at 1/5 and 1/4, okay, look at 1/5 on the top, look at 1/4 on the bottom. Which one is larger? Which one is larger? Miranda? 1/4. Okay. All right, can you see where this one comes out farther from 0 than this one? Can you see it? You can see it, can't you?
Mhm.
If we had a tape diagram rectangle and we colored them in, you'd be able to see it even better. Okay. Did I need to tell you with a number line that 1/4 is bigger than 1/5?
No.
Not really, because we have talked. Yeah, unfortunately I don't have fifths. But what do we know about the denominator? What do we already know that we've talked about? Yeah. Say it one more time. Okay, the denominator tells us how many pieces. But when we're looking at how big something is, what does it tell us?
The smaller the denominator, the bigger the fraction.
The smaller the denominator, the bigger the fraction. And since there's only one piece of each of them, this one's definitely larger. Okay. All right, so let's look at this down here on the floor for a second. We have a number line. I know that it might be hard for all of us to see exactly. Okay, but this is going to be our 0. Okay. And our 1 is down here. And if you can see it, what is our number line cut into?
Thirds.
Okay, it is thirds. Let's raise your hand, but it's thirds. Okay. So we would have, I'm going to tell you, you might not always see 0 thirds or 0 halves or 0 fourths on the number line, okay? Because sometimes we just know 0 is 0. You know, if it's 0, there's no fraction there. But I'm going to go ahead and put it since we have kind of practiced that. And then we would have the rest of them just like you've been doing on your board. We would have 1/3 at the next little, we call those little hash marks, those little lines. Sometimes they're called tick marks. We just mean those little lines like this. Hash marks, tick marks, either one will work. Okay, this would be 2/3. And then we know that 3/3 is going to equal 1. Okay. All right, so I don't know if it's going to work or not. If we were to put a container here, just about 1/3, 2/3. Try to make it into there. Yeah. I don't know if this is the best thing. I thought about a paper wad. Sometimes that's too light.
What's gonna happen to the
All right.
bubbles?
See, technically it made it in for like 0.5 seconds. And then it splashed right out.
1 millisecond.
Alright, I'm just going to try something right quick.
There's not paper. We don't need knives.
What?
Get the football out.
Get the football?
Yeah.
Okay. Just want to see how this.
Miss,
That way,
I
right?
think the future. It would make
I just want to see if it's going to bounce out or.
Well, first you gotta make it.
Thanks. I appreciate it. Y'all sound like my folks at home watching a football game. Take it into the end zone.
That hit the rim.
I feel like even though the bowl might suffer a little bit, the weight of the beanbag is going to be a little better. Okay.
How would you make it in a glass bowl?
So, do I really not have... There's a walkie-talkie on my table.
That's for the It's for you put it right there.
And I knew that we had one, but I just now have seen it. So, is it on right now? Even though the light's green? Why? It's charging. Okay, so in the afternoon, I flick it on and make sure.
To 4.
I left this on purpose. To 4, 4th grade, 4. Why is this on there?
I don't know.
You know?
The
Okay.
ghost.
Oh, recess in the afternoon, so that like if somebody gets called to go early or something. You know what? I was thinking like activity recess. I was going. Okay, so y'all are in charge, all of you, of helping me remember to take care of that. Okay. Did it help?
Yes.
You could hear better and all that? Yeah, it's crazy. This is going to be awesome. I don't think ever in the time that I've been here we all had one. Like we had one for the grade, but not each class. Okay, so what I was hoping, I'll just have to do it this way. All right, Will, come on up here.
I guess you
I did bring two. Okay. You're going to try to make it into, which one do you want to try to make it into?
3/3.
Okay. Now, okay.
Don't hit me in the face, though.
Now, we're not, underhand throw. Okay. Go ahead.
You missed at the picture. Oof.
Okay, go ahead and get it. We're going to give everybody 2 tries. Now, everybody may not do this right now. We'll leave the number lines on the floor this week. All right. One more try. Okay. We're going to count if it hits the ball at all as a.
It's over there predicting the future.
Okay. If it hits the ball at all, we're going to count that as a. Okay, you can have a seat for a second. Okay.
It's gonna make it, but it's gonna fall out. I think he predicted it.
There's just so much speed coming, you know. If that bowl was bolted down, maybe, or something. All right, Reagan. All right, you're gonna now. They're standing at the 0, and that's important. Okay.
What is gonna happen?
All right, stand right at the 0. That's where you want it to launch from.
I'm gonna make it to.
Which one of those two do you want to try to make it into?
No, 2/3.
Okay.
Darn it. That's what I was supposed to do.
Okay.
What did I say? Completely.
She hit the bowl.
Get another color.
Yep, she hit the bowl. Okay.
All
All right. So first of all, out of all 3 of those, who do you think, or which one do you think would be the easiest to make it into?
1/3.
1/3. We feel that way. Yeah. Okay.
But nobody.
So let me make this a little smaller, and then we'll. Okay. So weird. Let's put that back where it goes. What in the world? I don't know.
Are you an alien?
No. Most of the days I'm not. Okay. I can't say I'm not ever. Okay. So, Will, his landed in
1/3.
3/3.
3/3.
Okay. Reagan's landed in the 2/3 bowl. Okay, so we've got, hold on. We've got 3/3. We've got 2/3. Okay. One of the reasons that we want to be able to put fractions where they go on a number line is because one of the big jobs of a 4th grader is to be able to compare 2 fractions. Okay, here's 2 fractions. Could be any 2 fractions. Which one's larger? Which one's smaller? Or could they be equal? And we're going to have a whole section on what we call equivalent fractions. Equivalent means equal. No, this will come on down the line. Where, because sometimes a fraction has more than one name. Okay, so look at these 2 fractions and look at where they threw from. They both threw from the same starting point. Okay. Will's went all the way to the 3/3. Reagan's went all the way to the 2/3. Now, just by looking at the number line, which of these fractions is larger? Which one? Yeah. 2/3 is larger than 3/3. So this is larger here to 0. Use this. Let this help you. Is 3/3 picture from here all the way to 0? Or is this larger from here all the way to 0? Yeah, okay. So using the number line, just looking at that, 3/3 is going to be larger. Okay? Think of it this way. Where's my thirds? Here we go. Now think of it if you were hungry. Okay? Is that a larger piece to eat?
Yeah.
Or is that a larger piece to eat?
Yeah.
Definitely that. Okay. So one thing that's nice about pictures, whether it's a rectangle, a circle, whatever, it helps you see it. Okay? Just like looking at the number line helps you see which one is larger. Okay? Right here, we could see that 1/4 was larger than 1/5. But I want you to notice something else. These guys have the same denominator. We're going to get to where we look at two fractions that don't have the same denominator. Okay, 1/4 and 1/5 did not have the same denominator. But look at, they have the same denominator, so now I just have to think, okay, well, how many pieces are there? Because this tells me all the pieces are the same size. Well, if all the pieces are the same size, then I just need to know who has more pieces. Simple, okay? The one who has more pieces, that's larger if the bottom number is the same. Okay. All right. What should we cut our other number line into?
5th.
Tenths.
6th. 7th. 8th.
Millions.
10 million. 8th. 8th.
All right, let's do a little voting. We're gonna keep it a little smaller than 10. Okay. If you want to cut it into fifths, I think that's the smallest one I heard. Raise your hand. 1 for fifth. Anybody want 6?
Me too.
7s. Let's 8s.
Everybody.
Okay, let's go to the 8s. That's fine. All right, so give me just a second. Let me do a little math here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That didn't help anything.
We should do 13.
We do 13ths.
No, I don't.
So I'm scared.
All right, we know we need a 0.
I'm scared.
Let's just do this. Let's go. I need to go 6.5. 1, 2, 3, 4, 6.5. Halfway point.
80 million. 85 million. Infinity.
Love touching the floor.
You want me to help you, Miss Wendy? 5,
There's just one of us who touches the floor.
6, 7. I need to touch the lights.
You're what?
8. There's 8 notes.
All right, double check that there are 8 spaces.
8, 9. Wait, no. 8. There's 8. There's 8. There's 8. Every little team is 1. What's the denominator?
These little extras we don't have. I know, a lot of people get confused by that.
I'll get confused. 1.
You gotta look between the whole numbers, not the arrow. Okay. All right. So if this is 8, what goes here?
0.
Yep.
I definitely 0 over 8.
Alright. Yep, that's a great idea.
I'm gonna get Miss Wendy's gonna be out of sticky notes.
Yeah.
Hey, you got some What is it? It's how you say infinity You're gonna get cold for Christmas now. Now, why is he gonna get cold, Caleb? Because he said I ain't gonna get no presents, but he's gonna get cold. No, I never said that. Yes, you did. No, I said you're gonna get presents. Somebody put this on the board. You're gonna get this Christmas card. And it was made up my Christmas list. There's one more right here. I want everyone shopping and it's literally they want it under my tree. Exactly. And what was on it? It was like LED lights. When I did it.
Okay.
Like the fake
Alright, so let's put.
Can I throw?
Okay, don't ask. Alright. So.
I'm gonna go for the 8 8s. No,
Alright, Amanda, come on up here. Alright, we're only gonna put this to mark where we've thrown one because we've only got 2 of the beanbag. Alright, so where do you want to throw it to? Pick one.
4
4 8s. Okay.
1 8. I pick 1 8.
Alright, give that a try. Okay, good shot.
First wow. Hey, I'm gonna take the picture.
Alright, so we're gonna leave that right there to show that somebody did hit that mark. Okay.
Whoever goes next will hit the ball, but not me.
Alright, so Ishmael,
I'm not ready to 8
you're gonna try the 8 8.
8. I'm gonna miss. I'm not gonna miss. I'm still gonna miss. Hey, remember there's a person right
Okay, you don't have to get crazy or nothing. Just
I predicted
simple.
the future. You're gonna.
Okay, but listen, you can't go past the 0. That's important. Okay.
Yes.
All right, go ahead.
Hey, go ahead. Come on.
One more
Just
time.
pass the 0.
Alright, so now that you kind of feel what it feels like to throw it, catch it. Okay, make sure your foot stays at the 0.
0.
No cheating.
Hey, look at
You
your
have a
wheels.
centimeter past.
You mean like the breeze blew the ball.
The bowl, I did.
Alright,
cheated.
that's fine. Have a seat.
Yeah.
Alright,
He cheated. Okay.
so we can see if one more person can make it.
Yes, please, me. How many people can make it? Hey, I'm a wheel. I'm
Me.
Can I challenge you?
Gage, come on up and try.
Can you challenge me? Challenge me.
Stick your foot at the 0.
Watch Gage. Watch Gage.
Okay. Alright, so now you know to go a little softer.
I don't want to.
Yeah.
Not gonna beat 100, but no,
Okay.
I got closer to that.
Good try. Alright, last person to try 8 8.
The wheel.
Alright, what about 9?
Yeah, Charlotte.
Faith?
Any girl
I could really on
Go
that.
Faith. We need a girl to make it.
Yeah.
8 8 8 8.
Alright, keep your foot at the 0.
I'm recording. I'm getting another shot. I'm recording with my phone.
Yeah, don't let your foot go. There you go.
Please, I want everybody to just like.
Alright.
You keep taking
We
out
can't slide it. It's gonna have, you can have a seat. It's gotta land in it.
Can we do one more time? Nobody can do it.
Yeah, let
Alright, and there goes.
Look as
Okay. So, that way didn't work.
Is there a hole in it? Yeah, there's something.
throw it.
Yeah.
There's something in it. It feels like a
I know.
smaller
I know.
bag in the
I know, I don't know what that is. Alright, so let me pick a name. For some reason I didn't make this 6 to pull names in. I don't know why I didn't. Pick a name. Martin, you're the closest to my finger. Alright, which one? Let's go something different than 8.
No,
6,
go
8.
for 7. Yeah, 6. I'm going for the 7, 8.
Alright, remember we're not sliding it, we're trying to
I'm
get the
going
land
for
in
the
there.
0, 8. Imagine it just lands and it just.
Okay, whoa.
You're going for
Your
the
foot's
8.
gotta be it.
He's going for the 8, 8 touch.
Alright, let's try her. Okay, shh. We're not sitting chatting. Alright, so he's made it.
Good job on the second try.
Okay, so now we have 2 fractions. We've got 4/8. Let's turn this now. We've got 4/8 that Miranda hit, and we've got 6/8 that Martin hit. Okay, which one is farthest away from 0? Which one is farthest away from 0, Jayla? 6/8. Okay. It is the larger fraction. Also, look, if all the pieces are 8s, if all the pieces are this size, and if Martin has 6 and Miranda has 4, who has the most?
Me.
6. He has the larger amount. This is the larger fraction. Now, this may, again, like we've talked before, this may feel simple right now, but we're going to need these thoughts later on, especially, okay? All right. We're going to leave our number line for right now. We might come back to it in a little bit. But here's a question. Several of you, we had to remind, hey, put your foot by the 0. Let's put everything down right now. Okay. Put your foot by the 0. You know, don't go farther back. Don't go over the line. Why would that make a difference? If you're using a number line and you don't start it, you know, if somebody starts way back here or somebody starts way up here, why is that going to make a difference? Think about it, yeah.
If you start at 1/4, you're gonna have like a better. It's not gonna be the whole thing. It's just gonna be
Like a smaller piece? Is that what you mean? Yeah, it's a smaller distance, a smaller piece. Okay. What if you start way back? Martin, you kind of took this big step back, and at first I thought, well, he's trying to be careful and not throw it too far, you know, like sometimes you scoot back. And I guess I thought you might take a step. You know how some people will throw it that way? They'll take a step and then it could, but he didn't. How would that change things? If his fraction is from here all the way to his mark, and this one is from here all the way to their mark, his fraction is what? It's really bigger than it should be. It's farther. Yeah. Okay. All right. Let's see. What if we have, let me look at this for just some examples. I really don't want to get rid of that yet. Let's get rid of this. Okay. What if we have 4/5 and 4/10? Okay, now change the game just a little bit. The pieces aren't the same size anymore. I want you to turn and talk to somebody beside you and see if you can brainstorm any ways to tell how these are how can we tell which one is larger between those two? Okay.
Which one's 4/10? 4/10.
Guys, I need you not to get silly, whether I'm looking at you or not. Alright, so back together. Don't think I need to count down. Alright, I know it's Monday morning. I know we're dragging a little bit, but let me hear some good thinking. Okay? How can we tell, and there's an easy way to do this. How can we tell about these two fractions? Ishmael, what's something y'all were saying? But why? I really need to hear that. How did you know that? How did you figure that out? Kind of thing. Because of the denominator? What do we know about these two denominators? Well, without thinking about the 4 right now, what do we know about fifths? And what do we know about tenths? I've got the same number of pieces. I've got 4 of these and I've got 4 of these. Okay, so that's the same. 4 and 4. So what do I know about these two things? Yeah, well.
They're different because 5 is smaller than 10 and it's just half of 10. So
Okay.
5 is larger.
So these are larger or these are larger? Yeah. Well, let's just talk about the denominator though. Is fifths larger than tenths? Tenths? Yeah. I don't have tenths. I don't have tenths or fifths. That's not very helpful. But if I had a pizza and it was cut into 5 pieces, that's really not very. Okay, and then I had another pizza and it was cut into 10 pieces. Let's see. Okay. Sorry, those are not very even pieces. But which one has larger pieces? Everybody. Which one has larger pieces? Yeah. These pieces are larger. So if I have 4 of these, or I have 4 of these, who's going to have more? The fifths. Yeah, this is definitely larger. So if you have the same numerator, look at the size of the pieces on the bottom. If you have the same denominator, look at how many of those pieces that you have. Okay. All right. We're going to watch this, I don't know, it's 5 or 6 minutes. It's a little video. And the guys are talking about comparing fractions, and there's different strategies you can use like we were just talking about. We're going to watch that before we go on to our problem set. Actually, after this, we will take our break and then come back and do our problem set, okay? Let me find it. Where did it go? I think I got rid of it. There it is. No, it's not. Yes, it is. Yes, it is. Okay.
Hey guys, and thanks for joining me today. As you can see, we have a bit of a situation here. Those things following us are hungry space gators. They will eat pretty much anything that is big when they are hungry. We need to feed them some fractions to curb their appetite. Will you guys help me? Great, let's compare some fractions and let them eat the biggest ones. Before we jump in, let's remind ourselves what a fraction is. A fraction represents an equal part of a whole or a group. Here is one whole circle. This is a fraction, 1/3. The 3 or bottom number in a fraction is called the denominator. The denominator tells how many equal parts there are. To be a fraction, all parts must be equal. We have 3 total parts that make up the whole circle. The numerator tells us how many equal parts we are talking about. For example, the number 1 in the numerator is referring to the one green part of the circle. The fraction is 1/3 or one part of the 3 equal parts. When we compare fractions, we want to know if one fraction is greater than, less than, or equal to. If you still need a refresher, check out our last video on comparing numbers for 2nd grade. Here we are comparing 2/4 and 3/4. One great way we can compare them is by using models or drawings. When comparing fractions, you want to make sure the models or drawings, or rectangles in this case, are the same size. If we had different sized drawings, yeah, that would not work, so keep them the same size. Each of these rectangles is divided into 4 parts because the denominators are 4. The left fraction has 2 spots that are colored green, and the right fraction has 3 spots that are colored green. Looking at the 2 models, can you tell me which one is bigger or has more green? The fraction on the right, 3/4, is bigger than 2/4. The space gator's mouth always opens to the bigger number, so it wants to curb their appetite. Will you guys help me?
Did I just start that over?
Yes.
Okay, well, one of the strategies, and I may stop this every now and then, I want you to realize, because in a few minutes, you're going to have a problem set where you have 2 fractions, and you got to decide which one is larger. One of the ways to do it is to draw a picture. And by picture, what did I just get? You might draw rectangles and shade in the right number of pieces. You might draw circles. Rectangles are easier than circles sometimes. Okay? So that's one of your strategies. Where do I need to stop?
Keep going, keep going, keep going. Right there. A little bit more.
Now another way we could have compared these 2 fractions is by noting that the denominator is the same in both fractions. Both fractions have 4 total parts. This means that we can look at the numerator, and the bigger the number means that fraction is bigger. The numerator on the left is 2, and the numerator on the right is 3. 3 is bigger than 2, so we know 3/4 is bigger than 2/4. Here is a new problem where we need to find out if 1/4 is greater than, less than, or equal to 1/8. You might notice that the denominators are not the same. We are again going to draw or use a model to show the 2 fractions. On the left we have a circle that is divided into 4 equal pieces. On the right we have the same size circle that is divided into 8 equal pieces. The one piece in each fraction is colored green. By looking at the 2, which fraction or green piece is larger? If you said 1/4, you are correct. 1 piece of 4 is bigger than 1 piece of 8. Imagine that you have a pie that you are sharing. If you only share it equally with 4 people instead of 8 people, you will get a larger piece of the pie. Another way we can look at this is by looking at the denominators and numerators. The denominators are not the same in this problem. We have 4 on the left and 8 on the right. The numerators, however, are the same number. If the denominators are different but the numerators are the same, the bigger fraction will be the one with the smaller denominator. That is kind of tough to follow, but let me explain. The denominator with the smaller number means it is divided into less pieces. This one has been divided into 4 pieces, while this one has been divided into 8. The numerators are both 1, so that means the circle with the lower denominator is bigger. We have just one more problem to do, so hang on tight. Looking at these two fractions, can you tell me if 1/2 is greater than, less than, or equal to 2/4? If you said equal to, you are correct. Each of these fractions are the same, or equal, to each other. 1/2 is equal to 2/4. It is easier to see this because we have the models showing us what each fraction looks like. Drawing a model can help us compare fractions. I hope that you learned a little bit of how to compare fractions today. It looks like the space gators got their fill and are full. Wait, looks like one of them wants some more. I better lose this guy. See you later. Goodbye. Hey guys, you have a few options here. If you want to subscribe, click the red button below. If you want...
Okay, so think about the strategies they just told us about. You could draw a picture. If you need to draw and shade in the fraction to show you, and put it beside the other fraction. You need to make sure you draw the same size. Okay. And that's one that would have the same denominator. If they have the same numerator, the number on the top is the same. I don't know how to write this without it getting confusing. What would we do? If they have the same number on top, that means they have the same number of pieces. You gotta look at the what? You look at the denominator. To see which one of those is largest. If they have the same denominator, you look at the numerator to see who has the most pieces. Okay. Alright, so that will come in handy. We'll leave that on the board and that will come in handy when we see our problem set. Okay, there's not a whole lot of problems on it. We're gonna keep it kind of short today. Like before, we're gonna skip the word problem part. So we're just gonna stop this for right now.